Hey everyone, today I'm going to be showing you a retail site selection platform that I built on Databricks. But before we go into the platform, I want to take a moment to go over the geospatial capabilities that help me do that. If you're aware of the traditional GIS or geospatial analytics pipeline, you know that building out a decision making platform that heavily depends on geographic data can be quite the task. Your data comes from different GIS platforms with its own proprietary formats and indexing, so stitching them all together and deriving meaningful insights can be quite cumbersome. So the first key piece to solving that problem is on Databricks, you have native geography and geometry data types. So no matter where your data lives today, you can standardize them pretty easily. Secondly, when it comes to a specific business use case and all the data that you need for that use case, you're dealing with the same complexity of data. But the ingestion into Databricks is made easier with either your options on Marketplace or direct connectors to the source. You have spatial SQL and H3 functions that help you scale geoprocessing, and the resulting feature store feeds into your ML models and serving layer on Databricks. In my case, I'm using Databricks apps, and the operational database behind the apps is Lakebase. So at the end of this, you have a decision making platform for your business users to make strategic decisions. So this is Retail Site Lab, the site selection platform I built on Databricks. For this demo, I am using a fictional retailer called Clover and Co. They have about 240 locations operating out of the state of New York and have about 4 billion in annual revenue. They come in three different formats, so the express, standard, and flagship format. And we're also tracking competition and at-risk locations, which are your underperforming locations. So we think about the site selection problem. The first step to solving that business problem is understanding your network, understanding your top performing locations, and understanding the drivers behind the performance of those locations. The same goes for the bottom performers. You want to make sure you understand why certain locations are not doing well so that you can make sure not to replicate that pattern when it comes to your expansion strategy. So we will look at an example from one of the top 10 and one of the at-risk locations. This is location 1007, and this is the drive time trade area around that location. The demographic features come from the census data, and the POI density and trade area analysis comes from the OSM data. So, right off the bat, from this neighborhood level view, I can tell that when there's high population neighborhoods near the store, it's performing well because it's driving foot traffic into that store. Let's look at income. So, this clearly skews high income, so that could also be a contributing factor. Competition, there is very low competition in this trade area, so that's working in its favor. And POI density is not bad, not great either. And median age could be a factor if that makes sense for your retailer. So from this, I can already start seeing that high performance, high income, a moderate level of competition are going to be contributing factors to top performance. I'm going to redo this for an address location. This is location 1057. Let's zoom in. Okay, this is a flagship location, and I can already tell why it's not doing well. One is for a flagship location, this is a pretty small trade area. And within that small trade area, you have two other locations. So there's a clear situation where the stores are cannibalizing revenue between each other. So this is not going to work out as a great location, and it makes sense to drop this location. So you can deep dive into specific locations and see why certain areas are doing well, certain areas are not doing well. So you're well informed when you go into your expansion strategy with a strong hypothesis. You don't have to go into this business problem with just a hypothesis. You need data driven methods to validate what you're thinking. So let's use the site agent to understand what are the drivers of performance. The site agent is essentially a custom agent built on Databricks. Let's give it a couple of seconds. So this kind of validates what we saw in one of the top locations, which is that high income, high population, and a moderate number of competitors are going to be contributing factors for good performance. And another thing we didn't see but shows up as important is that POI density also needs to be high for good success. And this makes sense. We are essentially looking for areas with high economic activity. So, for the sake of this demo, let's assume that this is exactly what I'm looking for. So, I'm going to save this as a benchmark and I'm going to move on to my site playground. This is the site playground. As you can see, the benchmark that I selected and finalized in my network diagnostics tab shows up here, which is good. And there is a white space potential of 6.2 billion, which is also good. So for the sake of this demo, I am going to target just my urban locations, which is why you see the yellow dots concentrated in the urban areas. So I used the current network and built a predictive model to predict the annual revenue for each of these hotspots. So that is the revenue number that you're seeing associated with them. So what I'm going to do is ask my site agent for the best locations for expansion. And I have configured this in the backend to give me the top 50 locations for expansion so that I can get a sense of the neighborhoods it's targeting. Great. So let's zoom in here. So clearly, these are all urban locations. And let's assume that this is exactly what I'm looking for from a neighborhood level view. So what I'm going to do next is ask the site agent to optimize this network. What the optimize function would do is take all of these locations with high potential and run distance analysis with your current locations and make sure that when you get your output network, it's not too close to each other. You're not having an existing location and a new location right across the street, because that won't be good for your business. So it's asking me a couple of questions. So let's say 25 locations. Let's be more detailed. Open 25 locations, urban only, drop at risk, and anchor competition to 2028. Cool. So I'm going to run this now. Perfect. So I asked the agent for 25 locations within urban areas that it just showed me. And it looks like I have potential of 10% uplift in revenue, which is great. And it has dropped all the at-risk locations, which is good. And if I were a business user, I can also override the modeling results. So I can remove locations if I don't want, and I can save them if I like the results of this. So on the map, the green dots represent those final list of 25 locations that I selected. Again, as a business user, you have the flexibility to add a location, remove the location. So this is built around what a business user would need. You can also run this manually. Let's do this. Okay, let's focus on the same neighborhood actually. Let's say 2030. I care only about urban locations, so I'm going to make the suburban and rural metrics a little crazy, which is fine. And I'm going to ask for 10 locations. I'm going to keep it simple this time. Actually, let's just do 5 locations and I'm going to calculate the demand. So these are the top 5 locations that the model has selected, which is great. Let's look at the revenue impact. So it has about 2.5% increase in revenue if I expand to these locations. So as a business user, I can run multiple number of these scenarios and see what makes sense for my network. Additional thing that we didn't go over is that when we think about site selection, we also need to think about how competition would grow over time. And that's exactly what's done here. Let me do this. So if you had historic competition data, you can use a gravity model to see how competition would grow over time. So this would also be an input either to your predictive model or your optimization. So you have flexibility to do both. Let's anchor it back to 2029 and use the optimized locations. And that is the site selection platform.